Okay, let's go to page 361 and number 1. Okay, it says the frequency, so that's F. So frequency of the radio signal vary inversely, so equal to K over inversely as the wavelength. Okay, so let's go ahead and call that L. Okay, so frequency of the radio wave varies. So varies means you have the K, right? And very inversely as a wavelength. Okay, and it says a signal frequency equal to 1200 kilohertz, which might be the frequency of the AM radios, have the wavelength of 250 meters. Okay, so what frequency, so you're looking for F2, has a signal wavelength of 400 meters. Okay, so it's step the same, so you substitute to get the K, so you got 1200 equal to K over 250, and then multiply by common denominator. So this will cancel out, so K equal to, so 250 times 1200. Okay, so number is kind of big, so 5 zeros. Okay, so once you do that, you update your equation. So F equal to 300,000 over L. Okay, now you can go and use this equation to solve. So F equal to 300,000 over 400. So F will equal to, so divided by 400 equal to 750 kilohertz. Okay, again, the label should be the same. Okay, let's go to number 3. Okay, so the heat loss through a glass window. Okay, so let's go and call it capital L. So the loss through a glass window vary jointly means K times more variable as the area. So as the area of the window and the difference. Okay, the difference, I'm going to call it, normally you use a delta, but let's go and call it, use a capital letter D, the difference between the inside and outside temperature. Okay, now if the loss through a window with the area of 3 meters square is 720 BTU. Okay, again, this is the label for the heat loss. When the temperature difference is 15 degrees C. Okay, so it asks what is the heat loss. Okay, so this is first case. So what's the heat loss through a window with the area of 4.5 meters square and the temperature difference is 12 degrees Celsius. Okay. So again, make sure you read carefully and get everything done. Okay, so let's go and get the K. So you got 720 equal to K times area equal to 3. Temperature difference is 15. Okay, so to look for K, you have to divide by 3 on both sides, so you can cancel out. You have to divide by 15 to cancel it out. So K equal to, equal to 16. So once you find K equal to 16, you update your equation. So L equal to 16 AD. Okay, now you can use that to solve this part over here. So L equal to 16 times the area, 4.5, times the temperature difference is 12. Okay, so answer would be 864 BTU. Okay, let's go to the next one. Okay, for number 5, it tells you that it says in problem 5 and 6, use the fact that the intensity of light, so that's I, intensity of the light measured in lux is inversely proportional. So it's K over inverse proportional to the square of the distance between the light source and the object illuminated. Okay, so that's your equation. Okay, now let's go and get our case. So case 1 is says a light meter 7.5 meters from the light. So distance is equal to 7.5 meters. Light source register, so that's the intensity, registers 24 lux. Okay, so that's your first case. Now second case is what intensity, so you're looking for the intensity. Okay, so what intensity will register 15 meters from the light source? So the distance is equal to 15 meters. Okay, so again, let's go and substitute everything here to look for K. So you got 24 equal to K over 7.5 square. Okay, so cross multiply. So K equal to 24 times 7.5 square. Okay. Now, if it gets messy, you don't have to work it out, okay? But this one is not too bad. So 7.5 square times 24 equal, okay, so K equal to 1350. Okay, once you find your K, you update your equation. So I equal to 1350 over D squared. Okay, so now we can go and use this equation to solve. So I equal to 1350 divided by 15 squared. Okay, so we can divide by 15 squared. So equal to 6 lux. Okay, number 7. It says a sprocket gear 8 inch in diameter. Okay, so you got diameter equal to 8. It's connected to another gear with diameter equal to 3. How fast does small gear rotate on a large one? So this one, it rotates at 216 revolutions per minute. Okay. And if the small gear is attached to the 28-inch diameter rear wheel of the bicycle, how fast? Okay, so this D equal to 3. And this one D equal to 28. Okay, how fast does it rotate? Okay, so it gives you the hint. Okay, tell you that the revolution per minute times the circumference of the gear equal to K. Okay. So we're looking for 2 parts. Okay. So let's go and do this one over here. So to find K, we put this one in here. So the revolution per minute, okay, it tells you that is 216 revolution per minute, and times by the circumference is pi d, so it'd be pi times diameter equal to a. So circumference C equal to 2 pi r, and 2r is a d, so circumference is equal to pi times d, because 2r equal to d. So that's why I get this one. So equal to k. Okay. And so 216 times 8 equal, so k equal to 1728 pi. Okay. So once you find your k, you put in here to update your equation. So your equation becomes revolution per minute times c equal to 1728 pi. Okay, so now we can go and find out how fast is the smaller gear rotating. Okay, how many revolutions per minute? Okay, so revolution per minute times pi d, so pi, and the diameter is 3, so equal to 1728 pi. So to find revolution per minute, you divide by 3 pi. So revolution per minute equal to, this will cancel out, and so divided by 3 equal to 576. Okay. So this will give you 576 revolution per minute. So that's how many revolution per minute with the d goes. Okay. And so that's the first part. Then the second part, if a small gear is attached to a 20-inch diameter wheel, how fast does the wheel rotate? Okay, well, notice that because the way it's attached, the gear is attached with, so it will be the same. So the small gear turn 1 revolution, the wheel will turn also 1 revolution. Okay, so this would be a revolution per minute. Okay, now so it depends on how it's geared up. So in this case, because the gear is attached to the wheel this way versus this way. So this way is this kind of situation. Now if it's attached this, right, because it's fixed like that, so if this rotate 1 time, the wheel will rotate 1 time because they are together. Okay. Now if you have this kind of situation, if you have small gear and the wheels like that, then you have to use this equation. Okay. Anyway, so the answer is be 576 revolution per minute.